Alright guys, this is part 3 of the review. This is chemical reactions. I've already gone ahead and wrote down a lot of the definitions of these, so I wasn't talking and writing. So we'll just go over them really quickly, and you can pause the video to write them down. Molecule, remember, is two or more atoms joined together. What should be joined together? Okay, chemically, a molecule could be like O2, so those two atoms of oxygen. That's actually what we breathe in. A molecule could also be like H2O. Okay, now we have two elements, but we have at least two atoms. Okay, a compound is a molecule that contains at least two different elements. So H2O would be an example of a compound. O2 is not a compound. It is only a molecule because it only has two atoms of oxygen and there's only one element involved. H2O has two elements. Okay, so therefore it is a compound. So all compounds are molecules, but not all molecules are compounds. All right, a physical change, remember, is a change that is not involving a change in the substance chemically, so we can change it back. So example, like if I color this paper right here, okay, that is a physical change. It's still paper. I did not chemically change what it was. If I add Kool-Aid to water, that is a physical change. It's still water. I just added a Kool-Aid powder to it, and I could take it out if I wanted to. A chemical change changes what the substance is and makes a new substance. When leaves die, they turn red and fall off. They are from the tree during the fall. That is a chemical change. You cannot change that leaf back to a live leaf. Okay, a chemical reaction is a process that leads to the transformation of one set of chemicals into another substance. Okay, so we get something new. Evidence of a chemical reaction: odor change, produces a sound. You have a color change. And remember, that one's the one we have to be careful of and really think through because that could be a physical or a chemical. Temperature change, same thing. We have to think it through. We produce a new substance. We produce a precipitate. We produce gas, or we produce light. Okay, our chemical equation is our symbolic representation of a chemical reaction. Okay, these are our chemical equations down here. All right, now going through a coefficient, through the chemical reactions, and you talk about what a coefficient is. Remember, coefficient is our big number in the front. Okay, remember, a coefficient tells us the number of molecules. Okay, so for instance, right here, this is telling us that there are 2 molecules of silver. Okay, if there is no number in front of a molecule or a compound, then it is an understood one. All right, remember, our subscript is our small number. It's sub, so it's below. Okay, remember, a subscript tells us the number of atoms of each element. Okay, now remember, the subscript only goes to the guy that it's touching to the left. Okay, it does not share with anybody else. Okay, the coefficient only goes with the people that it is with. If there is a plus side separating them, it does not share over here. Our 2 would just stay with silver. Okay. All right, so now we got to go through counting our atoms and seeing if we're balanced or not. Okay. So we need to put out all of our elements. So we need to go through. Okay, we have C, which is carbon. We have hydrogen. And we have oxygen. Okay, and we need to make sure we have those over here: carbon, hydrogen, oxygen. Good, we have no new elements. Okay, so we're going to count on our reactant side. How many carbons do we have? Remember, this is our reactant side. These are our products. Okay, so there are no numbers. We have an understood one here and an understood one here. You don't have to write those. That's just for those of us that need some help. Okay, so we have 1 carbon on our reactant side. We have 2 hydrogens because we have a subscript of 2 and we have nothing here, which means it's a 1. Okay, and then we have no subscript or no coefficient, so we have 1 of oxygen. Now we come over here, okay, to our product side. We look at our carbons. We have no coefficient, so we have 6. Our subscript is 6. We have no coefficient, so we have to go with our subscript, which is 12. And oxygen, we have 6. So then we have to go through and check. Are we balanced? Do we have the same amount of reactants as we do products? Do we have the same amount of carbons on each side? We do not. Do we have the same hydrogens? No. Do we have the same oxygens? No. So this is not balanced. Okay. Let's go on to this one over here. Okay, so we have Ag, which is silver. We have hydrogen. And we have sulfur. All right. So we do have a coefficient here, but we don't have a subscript, so that's understood 1. So that means we are going to have 2 silvers on our reactant side. We do not share the coefficient because we have a plus sign. We don't have a coefficient here, so that's understood 1. And we multiply it by our 2, which gives us 2 hydrogens. We don't have anything here, so that gives us 1 sulfur. Go to our product side. We're going to have no coefficient, so we're going to have 2 silvers, 1 sulfur, and 2 hydrogens. So let's go through and check. Our silvers match, our hydrogens match, our sulfurs match, so yes, it is balanced. Okay. Conservation of mass. Remember, mass cannot be created or destroyed. Can only be rearranged. How can we show conservation of mass if our equations are balanced? Which means whatever I start with, I end with. Okay, just like in this equation, I'm starting with the same amount of mass that I ended with. It doesn't look the same because we took those atoms and we rearranged them through their chemical reaction, but we kept the same amount of mass. Okay, all right, let's go through this. Okay, our chemical symbol. Okay, we have hydrogen and oxygen. Our chemical formula, H2O. Okay. Oh, excuse me, we are just checking. Okay. All right. It is a chemical formula. Sorry, because we have 2 or more elements. Excuse me. It is a compound because we have 2 or more elements. Okay, number of elements, we have 2. Number of atoms, we should have 2 hydrogens plus 1 oxygen, so we should have 3. Okay, number of molecules, we only have 1 of these. So, we'll actually, okay. All right. Again, this is a chemical formula because we have more than 1 element and more than 1 atom of that element. Okay. Okay. This is not a compound because remember a compound is a molecule that contains at least 2 different elements. So we would stay here. Okay, it only has 1 element and we have 3 of them. So we have 3 atoms. Number of molecules would be 1. We only have 1 of these things. Okay, here we go. This is again a chemical formula because we have more than 1 element. It is a compound because we have more than 1 element. We have 3 elements, 1, 2, 3. Remember, in order to find a new element, you have to have a capital letter. Atoms, we have 1, 2, 3, 4, 5. So we have 5 atoms, and we only have one of these guys. So we have one molecule. Okay, He is helium. It is a chemical symbol. It is an element. We only have one element, and we only have one of them, and we have no molecules. Okay, same thing for silver. Okay, here we have a chemical formula. We have carbon and oxygen. We have a compound because we have 2 more elements. We have 2 elements. We have 2 of carbon, 2 of oxygen because we multiplied out. So we have a total of 4. And we have 2 of these, so we have 2 molecules. Okay, last part. Okay, talking about organic or inorganic compounds. Remember sponge. Okay, stands for sulfur, phosphorus, oxygen, nitrogen, carbon, and hydrogen. Remember, in our favorite one is carbon. Okay, so here we have sugar, we have carbon, hydrogen, and oxygen, so we are organic. Okay, salt has sodium and chlorine, which is not one of our organic elements, so we're going to say it's inorganic. Methane has carbon and hydrogen, so it is organic. Water has hydrogen and oxygen, so it is organic. Okay. Digestion, chemical or physical changes. We're just go ahead and finish this off on our last page. Okay. Physical, you're chewing. Okay, it's still your food. When it gets into your esophagus, it is going to start breaking down into your stomach and into your small intestines. Okay? All right. Now, why do we have food webs on here? Okay, because we're talking about chemical changes. We're talking about energy being changed in our chemical reactions. So part of what they want is for you to know that energy flows through an ecosystem. This is something that you learned in 7th grade. Okay, so it says highlight one complete food chain on the food web. All right, so one complete food chain would be my wheat to my mouse to my wolf. Okay, so my mouse eats the wheat and my wolf eats the mouse. Okay. Okay, who has the most available energy? So, okay, that question's always going to be our producers, which are these guys down here, because they get their energy from the sun. So they have the most available energy. Okay, the organisms that have the least available are always going to be our top level consumers. Okay, so here, for instance, like a hawk and our wolf, our top level consumers are going to have less energy because we lose energy as we go up through the food chain. So they have the least available. Okay. Draw arrows on the energy pyramid to show the direction of energy flow from greatest to least. Okay, so we should have, we'll use this again. We have the greatest energy going here. Okay, and then we start to lose it as we go up. Okay, so we have the greatest energy to the least amount of energy. Okay, I'm not going to go through and color all of these, but our producers are our greens. So these are our producers, our plants. Okay, our herbivores are going to be the ones that eat the producers. Okay, and our carnivores are going to be anyone that eats a herbivore. All right, and our last one, density. This is a 6th grade TEK. Okay, remember density is mass divided by volume. Okay, it's the broken heart equation. Think of it as a heart. Mass over volume. This, if you forget, this equation is always on your science charts. Okay, so make sure to use that science chart. It's on the back. Density, mass over volume. Okay. All right, so remember we take our mass. Okay, so we have this triple beam here. So we start adding up. We have 100 plus 20 is 120, plus 5 is 125. So our mass is 125. Okay, and our volume we have to do with displacement. So remember, we always look at the meniscus. So we started at 20. When we added our rock, we rose to look at our bottom of our meniscus, the bottom of where it dips. Okay, so the bottom of where it dips down. So after we added our rock, it went to 30. So our displacement, okay, we subtract 20 from 30, so our displacement is 10. So our volume is 10. Okay, and then we would do our math, which this is simple math. So you do 125 divided by 10. Okay, we should get 12.5. Okay, as our density. Okay, we will do some density work in class to kind of remember, but remember our mass is always going to be our scale, whether it's a digital scale or a triple beam, and our volume is always going to, for irregular objects, we're always going to use displacement with our graduated cylinders.